वो कल
Arulvi, can we start?
Yes, I am ready. If
Dr. Acharya, can we start?
Yes, absolutely. Yes.
Okay. Arulvi, you want to go ahead and start the meeting? Then I'll introduce Dr. Acharya.
Not you. Before that, I have to say a few words.
That's exactly what I'm saying. So you go ahead and start the meeting. After you finish, I will introduce Dr. Acharya.
So, greetings of the day to all of you on behalf of the Sir J.C. Bose Trust and the organizer. At first, let us pay our heartfelt homage to Acharya Jagadish Chandra Bose, a father of modern science in India, who made during the colonial period epoch-making contribution on radio science, time science, cosmic unity. Monumental studies in all these areas at that time. Well, today's distinguished speaker is Dr. Tinku Acharya. We are very grateful to you, Dr. Acharya, for agreeing to deliver a distinguished lecture here. Artificial Intelligence, Internet of Things and Influence in Modern Video Tech Computing. What an astounding title. We all look forward to hearing the lecture. I will request Professor Parthapratim Majumdar, a very distinguished scientist and a member of our trust board, to introduce our distinguished speaker, Dr. Acharya. I would now like to take the opportunity to mention with gratitude kind patronage of Dr. Acharya and his Institute Bidonetics to save Acharya Bhavan and Bose's legacy, treasured in Acharya Bhavan. Bose is a scientist par excellence, a essential polymath, a literature, a connoisseur of fine arts, a man whose genius transcended boundaries. Well, the year 2020, what is its historic importance in the history of science of India? The whole world is now hailing the success of J.C. Bose millimeter wave research in wireless communication. 5G technology, his microwave 5 millimeter holds key to 5G technology. The year is also very important history of Indian science as it marks the 125 years of the discovery of the millimeter wave by Acharya Bose. This year also marks the 120 years of the J.C. Bose's mesmerizing deliberation in the International Congress of Physics in Paris in 1900 in the responses of animate and inanimate objects. That is similarity between the living and non-living world, cosmic unity. The Mount Everest of Jagadish Chandra Bose's contribution towards advancement of science and technology that transcends time is his invention of the very sensitive contact diode detector of wireless waves. That inaugurated the revolutionary new era of long distance radio communication in 1901 and beyond. He made two patents, his two patents, British patents, one in 1901, one in 1902, on solid state diode detector device for wireless waves. Also one in US in 1901 for the same semiconductor crystal diode detector. So this was the evidence of the J.C. Bose's first technology transfer to the West during the colonial era. First technology transfer from India. J.C. Bose was not only a leader of Indian scientific renaissance, he was also a dreamer, an ardent lover of art, culture, philosopher, influenced by the philosophy of Upanishad and Buddhism, a patriot who recognized the importance of scientific research in national development. Bose, though well known as a scientist, but his spiritual thirst was so great that Lord Kelvin and Raleigh described him as a spiritualist like Swami Vivekananda. In his lecture at the Royal Institution of London in May 1901, he said that during the last 4 years of his findings, one truth permeates The diversity that we see here, one truth permeates through the diversity that permeates around us. That means unity among diversities. He mentioned this also in the inaugural address of Bosch Institute, founded on November 30, 1917. The boundary lines vanishing and a point of contact emerging between the realms of living and non-living. Bosch's discoveries in basic unity in all forms of life, similarity between living and non-living, and the concept of unity among diversity lend support to the cosmic unity of all existence long before the physicists or cosmologists could discover this. His scientific philosophy was thus disputed in Upanishad, that is avoidati, spirituality. Bosch's self-reliance to make instrument to achieve his great scientific mission is now forming the basis of Honorable Prime Minister Modiji's clarion call for Atmanirbharata in science and technology in modern India. Now, I would like to tell a few words about J.C. Bosch Trust and Trust Mission for our new friends who work for the first time here. Acharya Bhavan, a 120 years old grade 1 heritage of the city of Joy. Bosch built this Acharya Bhavan, his historical residence in 1902 at 93 Upper Circular Road, now Acharya Prafula Chandra Road, Kolkata 9, where the Bosch couple lived till their last days. Acharya Bhavan is a treasure trove of many personalia, memorabilia of the Bosch couple, many artifacts of historical importance. A rich repository of Bosch's original instrument, books, manuscripts, etc. Many of Bosch's pathbreaking experiments on plants, radio waves, cosmic unity were carried out in the laboratory, still present in this house. Acharya Bhavan also played an important role in the nationalist movement during the Bengal Renaissance, which then rolled over all over India. Here, Bosch played host to many luminaries of the country. Rabindranath Tagore, Swami Vivekananda, Sister Nivedita, Mahatma Gandhi, Acharya P.C. Roy, his notable students, S.N. Bosch, M.N. Saha, P.C. Mahalanabish, S.K. Mitra, D.M. Bosch, and many more. His interaction with world luminaries like Albert Einstein, Bernard Shaw, Marella, Lord Raleigh, Henry Cavendish, from these house, just to name a few, add to the glory of Acharya Bhavan. Acharya Bhavan restored the first national flag designed by Sister Nivedita in 1904. Murals and paintings by the renowned artist Nandalal Bosch and their contemporaries, antique furniture, sculptures, collections of Bosch, and many gifts of the world luminaries. Today, Acharya Bhavan stands as a monument to the many multifaceted genius of Acharya Bosch. It is the life and work of J.C. Bosch vis-a-vis the history of that era that is treasured in Acharya Bhavan, where science, arts, philosophy, and nationalism converge seamlessly. Acharya Bhavan thus has an illustrious past, a heritage which needs to be preserved at all costs. J.C. Bosch Trust, a trust founded by Bosch himself in 1931, has been entrusted to maintain Acharya Bhavan along with its movable and immovable properties to preserve Bosch's legacy and heritage treasured in Acharya Bhavan. This is separate from that of the Bosch Institute, Bosch set up in 1917. Mission of the present trustees of Sir J.C. Bosch is to develop Acharya Bhavan into a world-class science heritage museum in memory of Sir J.C. Bosch, just as Albert Einstein House in Bern and William Shakespeare's house in Stanford-on-Avon or Marie Curie's house in Warsaw were converted into museum. Well, once again, we thank with gratitude Dr. Acharya for his continued patronage to our mission. Now I appeal to all to support this great mission of this nation, since we believe Bindu te Sindhu. Bindu te Sindhu means Drops make ocean. So we appeal to you all to come forward to save this Bosch's legacy and the heritage mission of the nation. Now, I thank Dr. Acharya, Video Ethics, especially Jaya Ghosh, our co-organizer, National Institute of Biomedical Genomics, my colleagues, all the participants today for making the program a great success. We trustees extend cordial invitation to you all to visit Acharya Bhavan in trouble-free days soon. I wish I could show you take you to a virtual tour where J.C. Bose Science Heritage Museum is in making with some support from the Minister of Culture, Government of India, and philanthropic support from our friends like Dr. Acharya and others. Thank you all once again for patience hearing. Thank you. Professor Majumdar, please introduce now our learned speaker, distinguished speaker, Dr. Acharya.
Are you able to hear me, Parundi?
Yes.
Okay, excellent. So it's we have a very distinguished speaker this afternoon. It's really my honor on behalf of the Sir J.C. Bose Trust and the National Institute of Biomedical Genomics to welcome him. He's none other than Dr. Tinku Acharya. I have the privilege of introducing him. But before I introduce him, let me pay my deepest gratitude to Dr. Acharya for sparing his valuable time and providing this and agreeing to deliver this wonderful talk on artificial intelligence, Internet of Things, and video imaging and video photography. Dr. Acharya's research interests span a wide domain that includes intelligent video analytics, intelligent surveillance, image processing, computer vision, pattern recognition, and related VLSI and systems architectures. Dr. Acharya received his BSc honors in physics, BTech and MTech in computer science from the University of Calcutta, and obtained his PhD degree in computer science from the University of Central Florida in the US. Dr. Acharya has served on the US national body of JPEG 2000 Standards Committee as a part of the International Standards Organization for defining scalable image compression standard. His JPEG 2000 book is the definitive reference book in academia and industry circles worldwide for both software and VLSI implementation of this standard. Dr. Acharya's work significantly influenced the design of digital cameras in the early days and paved the way for transition of analog to digital photography. His work on coprocessor architecture for fast protein structure prediction is in the area of bioinformatics is the first published VLSI architecture known in this domain. So as you can see that Dr. Acharya has traversed multiple domains. He has served as a principal engineer of Intel Corporation. Additionally, he has worked for AT&T Bell Labs, University of Maryland, Arizona State University, Indian Institute of Technology in Kharagpur, etc. Dr. Acharya holds more than 150 granted patents in electronic engineering, electronic imaging, data compression, multimedia computing, computer vision, intelligent video, and VLSI architectures. He has published over 100 technical papers in international journals. He's the author of 4 books. Dr. Acharya is a fellow of the IEEE, INAE, IETE, and other institutions. He was recognized as the most prolific inventor in Intel Corporation worldwide, 1999 and in 2001. He became the first innovator to receive the prestigious Nasi Reliance Platinum Jubilee Award for Innovation in Physical Sciences from the National Academy of Sciences in India. After returning from the US in 2008, Dr. Acharya founded Videonetics as an R&D-led organization with a mission to solve challenging problems facing the world by creating and leveraging Indian intellectual property and deploying Indian technologies worldwide. For those of you who may not be aware, when you see the video cameras all over the streets of Calcutta, monitoring safety as also speed of vehicles, all of that has essentially been done by Dr. Acharya and his company Videonetics. Dr. Acharya, apart from the huge amount of erudition that he has and the inventive psyche that he has in terms of innovation and other various contributions to science and technology. Dr. Acharya is also a philanthropist, a very well-known philanthropist, and we are very grateful to him. We are grateful to him for kindly agreeing to deliver this talk from the podium, from the joint podium of the Sir Acharya J.C. Bose Trust and the National Institute of Biomedical Genomics. Without further ado, let me welcome Dr. Tinku Acharya, who will deliver a talk on artificial intelligence, Internet of Things, and video imaging. Dr. Acharya.
Thank you. Thank you very much. How much time do I have?
You can take 45 minutes to an hour.
Okay. All right. Okay. Thank you very much for inviting me to give this lecture in this learned community. And I understand that there are multidisciplinary people attending this talk. So I thought, these days lots of talks going on about artificial intelligence and IoT, Internet of Things, and my invention on video IoT, has been applied in many places worldwide. So I thought, since it is a multidisciplinary, audience, rather than going deep into the theory or mathematics and etc., to break the myths, there are lots of myths about AI, lots of myths about IoT. So to give a clear-cut understanding, what are these all about, and where it is going, and what is happening today. So that will be the nature of the speech, and hopefully I'll be able to cover in 45 minutes. Okay. So thank you very much again for giving this opportunity. So let's start with this particular video. A few years ago, when I was in USA to attending a conference, I saw this particular machine, and many known expert players tried to beat this machine, but could not. I was there more than 2 hours, but I could not, single person beating this machine. And this machine can predict the movement of the person, the speed, angle, all kind of features, and posture of the player, and can make a decision, how to tackle that ball and how to return it. So this is a example of an AI machine where artificial intelligence has been introduced into this, and also some Internet of Things, lots of sensors over there, and they're connected to the internet, and they are making certain decision-making process, and based on that, playing against that human player. So with this, let me start. What is this artificial intelligence all about? Before I go to the artificial intelligence, what is intelligence all about, right? So, some people say the intelligence is the ability to make right decision. So certain people are very intelligent people, certain people are considered not so intelligent. Essentially intelligent people we consider make the right decision, and decision is made based on certain criteria, and often using prior knowledge or training. So that is characterized one way, the intelligence, and this decision making and based on the certain criteria, in this, human intuition plays a major role. And this human intuition, that comes naturally since the acquisition of knowledge, in acquisition of the knowledge since the birth of the child. It's a lifelong experience. We are learning every day, we are experiencing every day, and intuition, plays a significant role. For example, when you see somebody or when we talk to somebody and we form certain opinion, right? So, and that comes because of the intuition. Is this good? Is this bad? Is it talking the sense? It is making sense? Whether it is the right or it is wrong, etc. And that intuition comes, because of the acquisition of the knowledge, and it's a lifelong experience. And intuition is formed based on the recognition of patterns, based on the experiences we have gone through, based on the incidences we have observed in our life. There are lots of patterns over there. When certain pattern matches, then we can make a decision, okay, this probably this probably this, that probably this. Even in the medical field, lots of case studies over there. When a new patient is presented, based on the data, case studies, the intuition, possibly this is the disease, or possibly this is the issue, and then goes into the detail, more deeper level of investigation. Same thing over here, intuition essentially it is nothing but a pattern recognition system for a machine, and modern psychologists characterize it that intelligence based on the intuition only. More intuitive people are more intelligent. Acharya Jagadish Chandra Bose, so much groundbreaking inventions, father of science in India. Unless he had the intuition, he could not proceed. Rabindranath Tagore, he was a very, very high intellect, intuitive person, intuitively could, gauge what is right, what is wrong, and how to make a decision. So modern psychologists say that human intuition is characterized by the pattern recognition, and pattern recognition is a subject, very important subject in the field of computer science, even in the statistics. Pattern recognition coupled with computer vision, that made the progress of today artificial intelligence. So then what is the artificial intelligence? We talked about intelligence. So artificial intelligence means when we let, as I said in the first slide, that making the right decision based on certain criteria, that is intelligence. If machine makes the right decision based on certain criteria, we call it artificial intelligence. And based on machine learning techniques, there are many machine learning techniques. And what does this machine learning techniques do? They essentially attempt to computationally model the world around us. Using a computational model, the world around us, based on that modeling, we make the decision, and that is the artificial intelligence. And machine learning has many branches. As I said, pattern recognition techniques plays a major role in AI. Without recognizing the pattern, without analyzing the pattern, is very it is very difficult to come to a conclusion. So pattern recognition is a very important aspect of artificial intelligence. And there are many branches, many domains into the artificial intelligence. When we started the research in early 80s, when I was graduate student, right, early 80s. So artificial intelligence that time is completely different what artificial intelligence today. It progressed a lot. So pattern recognition, there are predicate calculus, predicate logic, there are statistical techniques, many techniques over there. But these days, recently, because of many factors, which I'll discuss later, because of many factors, artificial neural network became very popular. And everywhere, every walks of the life, we talk about artificial intelligence, AI-based techniques, AI-based modeling. And AI-based modeling, mainly people are talking about these days, artificial neural network, deep learning, those kind of things. So rather than, talking about many other fields. Next few slides, I'll talk just artificial neural network, what it is all about, and break the myth, because many people has many kind of wrong notion. I spoke to many people. So I want to give the fundamental idea about what is artificial neural network. And artificial neural network again is nothing but computationally attempt to mimic the learning capability of the biological neural system. Our brain, human brain, or any animal, the brain, it is a billions of neurons over there, and that neurons, have the learning capability, and based on that learning, make some decisions. So artificially, how we can create the neurons, design the neurons, and network of those neurons, because those neurons are all connected. That's why we call it neural network. Network those neurons can make certain decision or can make certain conclusions. That is the fundamentally artificial neural network all about. So then what is the neuron? Before I go into that, I thought I should give certain, because particularly when I talk to the young people these days, they think artificial intelligence started, last 1 or 2 years ago, since everybody talking about AI these days. AI actually, it is more than 7 decades, almost 8 decades old. And Alan Turing is the founding father of computer science. Any computer scientist, they know Alan Turing is the founding father of computer science and artificial intelligence. He is the first one. He was a mathematician and biologist. He is the first one who posed this question: can machine think? And based on that, he did certain mathematical modeling, and he did some tests in 1950, and he has shown that certain intelligent behavior can be induced into a machine, and that was called Turing test. And based on that mathematical modeling, he came up with the concept of Turing machine. And in the world of computer science, entire computer science is based on this Turing machine, Turing theory. And to me, as a human being, fellow human being, to me the best contribution of this artificial intelligence was during the Second World War. Possibly that was the first AI technique, cryptanalysis. Germans, they were sending the, signals, messages, cryptographic messages. He was able to come up with AI-based techniques to intercept those messages and interpret what is all about. As a result, the Germans, their tactics, their plans, and etc., were known to the friendly, front during the Second World War. Because of that interception of that and taking the preemptive action, the Second World War were reduced by 2 years. And since it reduced by 2 years, estimate shows it saved more than 14 million lives. 14 million means almost 140 crore lives were saved. To me, that is significant. So this AI-based technique, by the cryptanalysis technique developed by Professor Alan Turing, that shortened the World War by 2 years and saved 140 crore people life. 14 crore, people's life. That is significant to me. So AI, essentially started from 1950s, more than 7 decades. Then, many people after Professor Turing, Professor Turing died in a very early age, at the age of only 42. But he's the question he posed, can machine think? After that, the Turing machine and etc. his fellow professors, and his students, and many other great scientists took it forward. One of them, that time we did not know it is called artificial intelligence, right? So essentially, Claude Shannon is another, legendary in the history of computing and communication and science. Claude Shannon is considered the father of communication. He first developed the theory of communication, theory of entropy, how to measure information, and etc. So Claude Shannon, McCarthy, Minsky, Rochester, these are all great computer scientists. They first coined the term artificial intelligence during a conference, Dartmouth Conference in summer 1956. So before that, people did not call it artificial intelligence, but during this summer conference only, that formal terminology was given, artificial intelligence, by Professor Claude Shannon, McCarthy, and others. So since then, the journey of artificial intelligence started formally, although informally, it started from early 50s. Okay. Then, Rosenblatt, he first invented the perceptron. Okay, and that was the beginning of neural network. Can machine perceive something? That is the theory he has given. So I'm not going into the detail. Then it was, advanced by many other scientists. Minsky, we are very grateful to Minsky. He first, developed the universal Turing machine. Alan Turing, he developed the machine, mathematical foundation. It's called Turing machine, but universal Turing machine was first developed by Minsky. And first time he wrote the book called Book on Perceptrons. And he first wrote a book in 1970s, Society of Mind Theory, how our mind works. Okay, these are all historical important things. Then followed by, Papert, he, essentially, developed the theory of learning. He first developed the knowledge machine, and in that sense, he first formalized this artificial neural network. Then, 1979, Professor Fukushima in Japan, he talked about multi-layered artificial neural network techniques. Initially, before him, it was single layer. And then backpropagation, many other techniques was involved into that. Then he gave this concept of neocognitron, multi-layered artificial intelligence. And this is the reason I'm specially mentioned this. This is what is, that planted the seed of deep learning today. Deep learning we hear everywhere, convolution neural network we hear everywhere, deep learning techniques. So that planted the seed. So this is the brief history and founding fathers of artificial intelligence and today's neural network. And that is the machine, Mark I perceptron machine, Professor Rosenblatt built, which could distinguish whether it is a, man or an animal. That kind of decision could take. That was the big machine he developed that time, in 1950s. So that is the brief history of artificial intelligence, and now let me get into little, deep into artificial neural network. And I apologize, I have to use little mathematics in the first slide, but I promise it will be very simple. So as I said, human brain, billions of neurons are involved, right? Connected neurons. Similarly, in artificial neural network world, what is a neuron? It is nothing but a mathematical function. Okay, it's a relation. So let's assume this is an expression, z equal to x1, w1, x2, w2, like this. And what you see here, essentially there are lots of inputs. Let's say x1, x2, x3, these are all inputs, signals. And every input or every signal, I weight by a weightage factor. Let's call it w. So we multiply them and we add them together. And we add a bias. So that gives this output Z. So Z equal to X1 W1 plus X2 W2, etc. In the world of signal processing, this is nothing but a FIR filtering, finite impulse response filtering. So essentially, we are multiplying two numbers. We are accumulating them, means we are adding them. M can be any arbitrary large number. Then we are getting certain result, Z. Then we normalize it. Normalize it means a normalization function in the world of artificial neural network, people call it activation function. After doing this activation function, I took at a sigmoid function. There could be any other function. Essentially, we are coming up with a single number which is between 0 and 1, a real number. This is what neuron all about. So neuron is nothing but a mathematical expression which converts all the inputs, given inputs, based on certain weightage. Weightages are defined based on the applications and experience and intuition that all we talked about. I'm not going into the detail. Coming up with a number between 0 to 1. That's what one neuron does. Now, if there are each dot over here, each circle over here, let's call it a neuron. Let's say a series of neurons over there. So all the inputs, x1 to xn, we call it input layer. We are sending that input data to one layer. One layer means a series of neurons. They will be computing based on the weightage factor, certain output. Then take those outputs, then send to another layer of neurons. It will generate little finer output. Then take that output, send it to another layer of neurons. Like this, we can go to multiple layers of neurons. You see, the Professor Fukushima said multi-layered. So this is a multi-layered. Okay. So in one layer, we learn little bit of information. Second layer, we learn little bit more information. Third layer, we learn little bit more information until we are satisfied with the information that we required. It is continued. So it is called multi-layered neural network. That brings the terminology deep learning. Deep means in between input and output, there are so many layers, input layer and output layer. Those number of layers, those are called hidden layers. How deep is determined by the number of such hidden layers. Okay. So if hidden layers are too large, it is very deep. If hidden layers are very small, it is not that deep. Instead of deep learning, I may call it, shallow learning. So deep learning is essentially in multiple layers. Decision is made at the output, and this number of layers, those are called the hidden layers in between input and output. Depth of the hidden layer determines how deep the pipe is. I'm using a lot of terminology. I have to use them. How deep is the pipe, or how deep is the network? So it is called neural, deep learning. That's why it is called deep learning. Okay. And mainly, it is nothing but a convolutional neural network. What is that? I'll talk a little bit about it. But before I do that, so why so many layers? Okay, what happens? I just want to show you a hypothetical example. Let's say, this image, because I do research last, 4 decades, I'm doing research in image and video computing. So these images are nothing but composition of pixels. Pixels are picture elements, right? So if you look at these particular pixels, you may not be able to, machine may not know what it is all about, right? If I do a little bit of processing, let's say I do the first layer of processing, right? Then maybe I can see some edges, edge information. Then I take it to the second layer. Maybe I can see some body parts, Maybe I can take it to the another layer, third layer. Maybe I see some faces. So that means, chromosoprocussion. Slowly, culturing or investigating or sending to the different layers of information, various features are coming out. First layer, maybe edges. Second layer, maybe some curves. Those curves can be some object parts. Third layer, maybe some human face. I'm just taking as a hypothetical example. If I do the fourth layer, maybe some expression, fifth layer. So like this, many layers you can go. And this is what happens into the deep learning world. This is the hierarchical representation or extraction of the features at a point where it can be detected and it can be recognized. So the entire thing, we call it convolutional neural network. What was the motivation? This is very interesting. I always like to talk about, the background, where from it came and bit in the science, right? This entire motivation came by studying the cat's visual cortex. So, somebody asked me, very interesting, when I'm seeing a fellow human being, I see a human being, right? When I'm seeing Parthoda, so I can recognize his Parthoda, and what I'm seeing Parthoda, can Parthoda is seeing the same thing on me? Or I'm seeing a dog, or I'm seeing a cat, right? So when dog is looking at me, is he seeing the same thing? What another fellow human being is looking at me, or dog is looking, what dog is seeing, or what cat is seeing? So very interesting. So study was done. When I was in Stanford, there was certain study was being done with a I have seen certain studies. How they perceive, various colors, how they perceive various shapes or shades or height or width or depth, etc. So based on the study, cat's visual cortex, it was found that different parts of the cortex, visual cortex, sensitive to different image field, right, rather than entire image. For example, in human eye, we have two types of cells, rod cells and cone cells. Cone cells are responsible to perceive the color. Rod cells are responsible to perceive or to understand the features, depth, height, width, and in absence of light, cone cells has no meaning. So if I take a person and put into a dark room, you will not be able to recognize what is the color of the shirt he or she is wearing, right? In presence of the luminosity, chroma has certain meaning. So these all came with the study of the visual cortex, and from the cat's visual cortex, this convolutional neural network came. I wanted to spend few minutes so nothing is just, everything there's a reason why convolutional neural network there, why deep learning techniques are over there, and what is this convolutional neural network all about. After giving that history, let's assume the input is an image of size 28 by 28. So what it does essentially, it does a convolutional operation. And convolution operation is a linear convolution operation. People in the mathematics or statistics, they know all about it. I am not going into the detail. Linear convolution, in the signal processing world, it is two-dimensional FIR filtering. Okay, so essentially concept is the same. So we are doing this convolution of operation, sliding through. By doing that, there is certain concept of stride into the neural network. I'm not going into the detail of that. It creates 4 feature maps of size 24 by 24. You can see the input size was say 28 by 28 elements. Output of that, after doing the convolution, or in image processing world, it is called signal processing world, it is called convolution, or FIR filtering. Image processing world, we call it feature extraction, or neural network or AI world, we call feature extraction. So after doing the feature extraction, we are getting 4 feature maps. So 28 by 28 input, output is 4 multiplied by 24 by 24. That means data is growing. And in a digital computer, if data grows exponentially, very difficult to handle. And it has been seen in multimedia computing, or in image or video or audio or speech, there are lots of redundancy. For example, in image, neighboring pixels are correlated to each other. What do I mean by that? If you take an image, say 1K by 1K image, if you take alternate rows and columns, it's a two-dimensional signal. Just throw them out, it becomes a shorter image, right? Still, you'll be able to recognize this is Tinku Acharya, this is Partha Majumdar, this is Parul Chakraborty. That means features remains there. That means there are redundant information. If I throw away the redundant information, just maintaining the actual information which we need, we can recognize the content of the image. So that is called, in signal processing world, subsampling. That means after we are doing the feature extraction, I am doing 1:2 subsampling. 1:2 subsampling means I'm just throwing away, assume this is a two-dimensional, assume this is a 2D matrix. In the 2D matrix, every alternate rows and columns, if I just simply drop, then this 24 by 24 matrix becomes 12 by 12 matrix. So you can see, just by doing the subsampling, I'm arresting the growth of the data. So input size was 28 by 28, output size becomes 412 by 12. So this is nothing but redundancy reduction. And this redundancy reduction, neural network world, people call it, pooling. And what is that? I'll show in the next slide. So this is one layer, right? In layer one, I have done certain convolution, convolutional, mapping, doing the feature extraction. I'm subsampling it from 28 by 28. I'm generating 4 12 by 12 feature map. I can take those 4 12 by 12 feature maps, again go to the same thing in layer 2. Then I'm creating 12 4 by 4. Then I'm creating, final layer output. I'm generating 26 1 by 1. So those are the, model information by it's called the vector. I can use it with matching with the input image and can make certain decision. I'm not going into the details. So this is essentially what happens into the convolution neural network. And I talked about pooling, right? So here is the original data in the left-hand side. We are doing the convolution. Above is the sampled image. After doing the convolution filter, we are getting the filtered data. Then pooling, subsampling, how I do the subsampling. Let's assume there is a 4 by 4 matrix. And each, for example, a red 2 by 2 matrix. If I take the maximum of those 4 values, that is 58. Green, blue one, maximum of those 4 values is 32. Like that, if I do, it is called max pooling. Instead of maximum, if I take the mean value, it is called mean pooling. And depending upon your application, you can come up with other pooling techniques also. Essentially, this is what happens inside. In a very nutshell, in the convolution neural network or deep learning world, this is what happens, right? You can appreciate this is computationally very, very intensive. Although these things were known, artificial intelligence was there, since, 50s. And this neural network, since 70s it was going on, 80s, 19, deep learning technologies, convolution neural network happened, but there was not that widespread application. The widespread application was into the field of defense and etc. Because in the consumer, in civilian applications, that kind of computing capability was not there. With the advent of my expertise in VLSI, computer architecture, with the advent of the computing architecture, today huge volume of data can be processed in a small computer. When we were student, in ISI or Calcutta University, big IBM 1130, machine was there, right? And that machine was very slow. Memory was only 16 kilobyte. But today we are talking about a laptop, more than 2 gigabyte memory. So huge volume of data can be processed today. So that's why, this artificial intelligence became popular because it is possible to process those data in real time or near real time. So let's talk about this evolution of computing little bit, why it is possible. These days you hear everywhere GPU. Because of the GPU, this neural network or AI-based techniques became such a mainline, subject, and it is being applied everywhere, even in the chemistry. These days people are applying these deep learning techniques. You don't have to do, a lot of times chemical, I was told, you take two chemical equations, and by doing what will be the outcome you can predict. Then in the lab you go and do it, and how it is predicted based on many case studies and data, etc. Similarly, in the genetics, in the biological signal processing, lots of deep learning techniques are being applied over here, and that is possible because of the GPU. GPU means graphical, early 90s when we developed the GPU, that was mainly meant for, display, on the computer terminal, how to display that, or in the monitor, how to create the images. That was mainly the purpose. That's why it used to be called graphical processing unit. But these days, in last one decade, it is not just for the rendering of the image. Lot of computation also can be done. So that's why these days it is called general purpose GPU. All of you know, you talk about Xeon processor, 4-core machine, and what does 4-core means? Or 8-core machine or 16-core machine. That means in parallel, there are 4 arithmetic logic units are working. Arithmetic logic units mean they are doing the mathematical computation. Simple language. In the GPU world, general purpose GPU, instead of 4 or 8, these days there are thousands of such computing elements can be processed in parallel. So left hand side, that is the CPU, central processing unit. Right hand side, that is the GPU, general, graphical processing unit, general purpose graphical processing unit. After this became popular, so each and every server machine these days, today, from last couple of years, what it started, in addition to the CPU, there is a GPU. That means lots of similar kind of computation is thrown away there. I'm not going into the detail. That is called vector processing. Okay. And this GPU is very much suitable for artificial intelligence. And new, programming paradigm or new computing paradigm came up in the last one decade, which is called SIMT. So what is that? People who goes to the computer architecture class, there are 4 types. SISD means single instruction, single data. SIMD, single instruction, multiple data. MISD, MIMD. So essentially here it is SIMD. Number of SIMD. SIMD means single instruction. Same computation is being done on many input data. That's what happens in image processing. Same image, same operation is happening in all the pixels. Okay, so SIMD operation. Many such SIMD operations are happening in parallel, and that's what GPU all about. So each SIMD, and as a result, it can handle huge volume of data. Per second, billions of operations it can do it. Billions of operations, billions of pixels it can process. So each SIMD is a vector operation. Each vector operation is called a thread. And these days in the programming language, people talk about single threading, multi-threading. It came from here, from the vector computation. Multiple such vector operations are happening. Each vector operation is a thread. So single instruction, multiple thread. So computer architecture, it was SISD, SIMD, MISD, MIMD. Now in the new GPU world, new programming paradigm, it is called SIMT, single instruction, multiple thread. Result, billions of data can be processed in a fraction of a second. And that is the reason cloud became so popular today. Okay. And I'm not going for the details. So this storage, earlier storage was very expensive. As I said, in 80s, when we were student, our computer had only 16 kilobyte memory. So now even a little laptop, it can has several gigabytes memory. In future it will be petabytes. So storage became semiconductor storage. Earlier it was magnetic. Currently it is semiconductor. That's why you have the USB and etc. So storage became very compact. Huge storage is possible to manage and became cheaper. Computing is possible today. Process billions of bytes in a fraction of a second, and the pricing went down. As a result, it is no more restricted to the defense kind of operations. Even with a little computer, we can do many such processing. Research has enhanced communication from multiple locations, from distance locations, through the telecommunication network. Data can be transmitted from your machine, or from the sensor, or from one location to another location. Data can go to the cloud, it can process over there, the process results can come back. So cloud and combination of these four, storage, computing, communication, and cloud, and their advancement made AI possible today. This is the background. Okay. Now let me give little background of IoT. I feel excited to talk about IoT. These days, everybody talks about IoT, and it is like how to describe an elephant. If I ask an blind man to describe an elephant, IoT is like that. So that's why I wanted to break the myth. What is IoT all about? So if you look at the internet evolution, in early 80s, it was internet of documents. Email, document can be exchanged from one place to another place. Then internet of commerce started. Banking industry, insurance industry, they started to connect with each other, transferring file from one place to another place, file sharing. So that was the internet of commerce. Then internet of applications. Today it is internet of people. I am talking to you, people. I am not talking to a machine. Although I am talking to a machine is talking to you, right? So all the audience, these are people. When I'm talking over the cell phone, I'm communicating with people. When I'm sending an email, I'm sending it to people. So internet of people, interconnection of people. Next decade, already this decade started. In next 1 decade, things will be connecting with each other. Your devices will be connecting with another device. They will make the decision in your absence, right? That is the new era, which is called Internet of Things. So this is the evolution. So what is happening worldwide at this moment? Just at this moment when we are talking, what is happening? In 60 seconds, 168 million emails are being sent, so many Google search or other kind of search happening, so many Facebook messages going, so many data is being created into social media, huge volume of data is being created, transmitted into this connected world, right? What is the generation of the data? It is approximately 20 quintillion bytes, 20 into 10 to the power 18. This amount of data is generated every day today. The moment a child is born, I was told 200 megabyte data is generated. Immediately you take a picture, you send by WhatsApp to somebody, that somebody sending the WhatsApp to some another group, and throughout the world that it is moving around, right? And we all these days, we are very happy with your cell phone. Every time we click the button in the cell phone, number of clock pulses traveling through this world. You think about it, what is the implication? tremendous amount of power consumption is happening, tremendous amount of data storage is traveling through the communication network, going to the cloud storage, etc. Okay, in this world, billions of sensors are deployed. Your cell phone is a sensor, and the CCTV camera on the road we see, that is a sensor. In these days, modern, refrigerator machine is a sensor. People are talking about Apple Watch, those kind of things. These are all sensors. Your credit card is a sensor. So all these are sensory elements which is generating certain data, and that data is communicating from one place to another place through the communication network. The moment you charge in your credit card, certain information which is encrypted in that card, behind that magnetic or the whatever it is there sensor, that is going from one place to another place. And in that another place, some decision making is happening, then you are able to make the charge, etc. So data is moving all over the places. If you look at a modern car today, there are so many sensors. So in 1999, Kevin Aston, he first gave the concept. He was a supply chain manager in Procter and Gamble. He first envisaged that all these physical objects, if we can attach a radio frequency, RFID, we all heard RFID. If we can attach an RFID to each and every physical object, then we can track the locations of those objects, right? So he is the first one. He gave the terminology, Internet of Things. And the 1982, that time it was not called Internet of Things. The first IoT machine actually was developed by Carnegie Mellon University, 1982. They had this Coke machine. Okay, in the Coke machine, the weight of the Coke cans, those are there. The moment number of cans into the machine goes below certain threshold, immediately it used to send a message somewhere that this is the time to fill up the Coke machine. Then people used to come and fill up. That means there is a sensor inside that machine. The sensor can sense it is the time to fill up. Then the message is going there and somebody is taking action. So although they did not know or the terminology did not come, but that is the first Internet of Things in the history of IoT. Formally, the IoT terminology was given by Kevin Aston. Then later it was formally defined by the scientists and professors like us, and we made it very, very complicated. Because that is our tendency, professors and scientists, to make things very, very complicated. So he was a simple guy. He called Internet of Things. And we gave the terminology, what is the things? Things is inextricable mixture of hardware, software, data, and services collectively called objects. Don't ask me what it means. To me, it means everything. Hardware, software, data, services, collectively called objects. Those are things. And when those objects are connected to the network, it is called Internet of Things. That means Internet of Things is the network of physical objects, devices, vehicles, buildings, animal, people, any other item which is embedded with electronics, and that electronics is run through a software, and the software, by processing the data, it can generate certain information, collect and exchange data through the network. That is the formal definition of Internet of Things. Now many people call many different ways. Kevin said Internet of Things. Cisco call it Internet of Everything. Essentially, the previous, slide, the definition I gave, it is actually everything. What is left there? Devices, vehicles, building, animal, people, any other, so everything. So Cisco call it Internet of Everything. Intel calls it I for everything. Machine learning people like us, we call it machine-to-machine communication. Bruce Snyder called it world-size web. And if you look at it truly, all the cell phones throughout the world, so many billions of cell phones, they are all communicating with, it is in the connected world. It is essentially a world size web. And in the Terminator movie, they use the concept Skynet. Essentially, these are all Internet of Things in various avatars. So in nutshell, so what is the ultimate goal of IoT? In 2010, in this decade, 2020 now, so it is interconnection of people. People are communicating with each other. 2020 and onwards, the goal is things will be communicating with each other. Devices will be communicating with each other. There is no role of the people over here. I'm just giving you a hypothetical example. Every day after your work, you go to home, you want to have a cup of coffee, and that coffee should have a particular temperature, particular amount of, sweet or milk, etc. So you are driving, your car will be recognized by a camera. The moment, recognized, such person is going towards the home, approximate time of arrival to that home, maybe 3 minutes. And that message is being given to a coffee machine. Coffee machine knows this gentleman will arrive here in 3 minutes. So exactly when to start making the coffee, exactly what temperature he like to be served, what is. So everything in a very high precision manner will be served to you the moment you enter the home. I just gave you just hypothetical example. So that is Internet of Things. And this is very, very important today. We scientists, technologies have to get involved. Otherwise, disaster can happen. I'll explain you later. Because it is the fastest growing technology field. 2010, world population was approximately 6.88 billion, 7 billion. And connected device in the world was approximately 12.5 billion. Connected devices, that means, this Internet of Things devices, sensors, 12.5 billion. These days, people even carry more than one cell phones. And I hear many people, even the lady who works in our home, in her cell phone, she uses 2 SIM cards, right? So multiple devices each person is carrying. World population, currently it is approximately 7.6 billion. Very soon it will be 8 billion population. And connected things will be 212 billion. So think about it. 2010 connected device was 12 billion. That is 1.8 times world population. 2020 and onwards, it is heading towards 28 times of the world population. Think about its implication into the nature. So many devices, so much data, so much communication has to take place. Computing them, communication, transferring those data, amount of power consumption will be required. And what kind of VLSI design will happen. So the low power devices are available, etc., etc. So computer scientists, electrical engineering, signal processing, statisticians, mathematicians, including psychologists, they have to work together in a multidisciplinary manner if we need to tackle it properly. Why? Maybe in a different lecture I can talk about it. So tremendous amount of growth is happening. 50 billion smart objects, and each smart object always continuously generating the data. So, and on top of that, today, cyber security, that is cyber security, has to be dealt in a very, serious manner in the world of IoT. So to me, IoT, if understood, truly secured, IoT can enhance communications, lifestyle, and delivery of services, like one hypothetical example I gave you to serve you the coffee. But think about it. People are talking about driverless vehicles. IoT world, we are talking about devices will be communicating with each other and making the decision by themselves. And this, just hypothetical example, all these driverless vehicles, they are running, and who is guiding them? From all the sensors, this data is going to the cloud, and from the cloud, decision is coming to them, and accordingly, the car is maneuvering itself. Now, if some hacker gets handled into this, hacks those vehicles in the city of Calcutta, all of a sudden, 100 vehicles running randomly more than 100 kilometers per hour in a Brownian motion fashion, what will happen? Worse than an atom bomb. So that's why IoT world, still I'm not seeing too much seriousness from the scientists and professors and the researchers. So if misunderstood, if half-educated people develop the IoT machines, it can create a danger. So if understood, truly secured, IoT can enhance communication, lifestyle, and delivery of services. If misunderstood, misconfigured, and IoT poses the risk to our data, privacy, safety, and life. Okay, that's what I have to say. Now, this video IoT, this terminology I coined a number of years ago along with Intel Corporation. So usually I give, tutorial on video analytics, days long or 2 days long tutorial, but I'll give you 30 seconds tutorial on video analytics. So this is the sculpture of David, one of the brilliant sculptures. And this is what Michelangelo said. He said, I saw the angel in the marble and carved until I set him free. That means there was a stone, just carving the unnecessary portion of the stone, took it out, Michelangelo came out. David, statue of the David came out. Video analytics is exactly the same. Huge volume of video data. Professor Mojumdar, he said in the city of Calcutta, there are thousands of cameras over there, CCTV camera over there. Are those being utilized? If you go to the airport, so many CCTV cameras over there. So all those video data is being collected in real time. Behind, from all this video data, analyzing, you get some actionable information you generate. Generation of that actionable information out of that huge volume of video data, that is video analytics. That is one of my favorite subject, and that's what video analytics is doing about. So this is my popular preach, particularly in the space of IoT, in the space of video analytics or video computing. We need to develop indigenous technology in India. If we think, all of a sudden people will come from America or Europe and make the India country great, no, they are not going to do it. Okay, to solve our indigenous problem, we have to develop indigenous technologies. Why? Look at here. This is my home in Phoenix, Arizona. Look at the local traffic conditions. Do you think the traffic management technology, which is deployed in United States, in Arizona, if I bring the technology and dump into Maulali, Kolkata, it is going to solve our problem? It is not. This is the traffic condition in the highway. Do you think if I bring that and put it into New Delhi, that area, it is going to solve our problem? No. So just dumping foreign technologies and foreign solutions in Indian soil, most of the time they do not work. Our demography is different, our cultural condition is different. So based on the demographic conditions, we have to develop our own technology, and we took advantage of video analytics. Many Indian problems we solved. Believe me, it gives me the pain when I go to many engineering colleges and universities, and when I see their BTech thesis or MTech thesis and PhD, most of them are junk, worse than toilet papers, cannot be used. They look at few journal papers, they find the loopholes and try to plug the holes. In the society, I'm talking about the engineering field. I'm not talking about the biology or other science. I'm talking about engineering, computer science, etc. There are so many challenging problems. If we can take these problems and take as a research topic, hundreds of fantastic PhD can come out, thesis can come out, and good publications will come out. One of the example is this. In video analytics, there's certain thing called unattended object. When you go to the airport, often you hear in the announcement, if you see some bag or something unattended left, please inform the security guards. I have never seen any person informed any security guard because we don't care. This is a platform in Europe, morning 6 o'clock. I took the picture and there is nobody. Just 5 minutes before the arrival of the train, platform is empty. Train arrives, people get down off the train in a very well-disciplined manner. People board the train, train leaves, and the platform is open. So if somebody leaves a bag over here, it does not require a rocket scientist to find out, to identify that there is a bag sitting over there and nobody attending it. This is Howrah Station, morning 6 o'clock. So do you think bringing the technology, automatically detecting unattended objects, dumping into Howrah Station is going to work? It is not. So for the sake of Howrah Station, our cultural condition, our demographic condition, we have to build our technique, and we have developed that AI-based techniques in this condition. If an object is unattended, can be identified. And that is deployed in more than 86 airports in the nation. And I can assure you, Indian airports are very, very secured. Here in the street of Tokyo, this gentleman left this bag and walking away. Very simple to develop the technology. But if I bring the technology and put into Delhi street, I don't think that technology will be that effective. So we have to develop our own technology. Traffic management, so in India, there's an issue. People don't wear, many times people don't wear seatbelt. It is not only in India, throughout the world. And it is not possible to deploy police personnel every 50 meters on the road. So there are so many CCTV cameras. These videos are being generated in real time. Can we detect that that person is not wearing a seatbelt? It can be done by AI-based techniques, and it is being deployed in many, many cities in India. We have developed it using our video IoT techniques. So essentially no human intervention there. Police need not stop you. Okay. Using the normal CCTV camera, as long as picture quality is good, analyzing those, you can say whether the driver is wearing seatbelt, whether the passenger is wearing seatbelt. It has been deployed many, many places. This is one example of IoT. People do not wear helmets, right? It's a dangerous thing. So people who are not wearing helmet, automatically detecting that. I was told in Calcutta, there are certain areas people dare to stop them, right? Police dare to stop them, right? Because there will be lots of interventions. But if the machine is making those decisions, no human intervention is required. CCTV camera, all, this video is analyzed in real time using GPU and detecting this is the license plate number, this is the vehicle, this is the snap of the vehicle, and this is at that instance, in the accuracy of milliseconds, at that particular time, this vehicle was seen. There are 3 people, triple ride is happening. Out of those 3 people, 2 people are not wearing helmet. Then recognizing the license plate to that home, and warning can be given. First time it was deployed in Indore, city of Indore. I think 2018 or 2017. Oh, it shows 2017. This is called challan, e-challan. So that means this is the this is the license plate number. Accuracy of a fraction of a second, 10th, 9th October 2017, 4:41:56 that PM. This person was shown on the vehicle. The timestamp is given with that accuracy and not wearing a helmet. And at home, challan is being sent because automatically recognizing the license plate, from the motor vehicle database, the name of the person and the address can be, extracted. And using that video IoT, applying the video IoT, this kind of practical applications can be done. First time it was deployed in city of Indore. Unfortunately, in Calcutta, it's not done yet because we are the Geojogi Bhikpaina, na? Since we are from Calcutta, nobody gives a damn. So similarly, we are the first one in the world using the normal cell phones, the normal CCTV cameras. If somebody driving the car while talking the cell phone can be detected. So these are some of the things. I was given only 45 minutes, and let me show a few other examples. It is not only traffic management, in the municipality, how to keep our city clean. I know a lot of technologies has been developed, and in some places it has been deployed also. You just watch this video. Let me give a rest to my throat. So the thing I was trying to show, this has been deployed in Chennai, certain areas in Chennai. So message I'm trying to give, we can, to keep our city clean or our neighborhood clean or our, housing complexes clean. We don't need to deploy people over there. Normal CCTV camera analyzing those video in real time in the background. The moment garbage bin is being overflown, it message can go, garbage bin is overflowing, please clean it. Then once it is clean, it will again send the message, yes, it has been cleaned. So in between garbage bin overflow and clean, how much service time it took. This AI-based video IoT is being used in
Dr. Acharya, am I audible? This is Partha Majumdar here. Parulli, are you able to hear me?
Yes, I can, but I think we lost him. We lost him.
I think we lost Dr. Acharya, and I couldn't actually hear the last 1 minute or so.
Yes, me too. But he's here. Dr. Acharya is here. Ankita, please come.
He shows as muted.
Yes.
Dr. Acharya, can you unmute yourself, please? Vikram, is it possible for you to unmute Dr. Acharya?
I think he left. He's facing some difficulties in logging again. Let me check.
Well, fortunately, his talk was over, so it's okay. Well, anyways, Parulli, can you send me Dr. Acharya's telephone number? Not right now, later. At some point of time, I would like to personally thank him. You thank him as, oh, there he is. I saw him just now. Why guest? Can you make Dr. Acharya a participant, Vikram?
Can you see him?
Yes, Dr. Acharya, are you able to hear us?
Yes, I don't know what happened all of a sudden.
Something happened all of a sudden. The last 1 minute or so, we lost you. We saw your video and then Q&A, and then I don't know what had happened. Anyway, fortunately, there was no problem while you were speaking. It's just the last maybe 45 seconds or so that something terrible happened. I don't know. I think most people cannot ask questions. I have a comment to make, and I don't know. I will thank you on my behalf and then hand it over to Parulli. My comment is that you are a fantastic teacher. I wish I had taken some courses from you. I would have learned a lot. That's all I would say. Of course, you are a great researcher. Of course, you have contributed so much. But what I have been impressed with is that I've heard many talks on artificial intelligence, deep learning, but today's talk was absolutely stunning in terms of ability to communicate simply to those of us. I of course have a mathematics background, so it's a little bit easier for me, but even so, the ability to communicate difficult things so well, I was extremely impressed. Of course, like I said, that the practical applications and the theory that goes behind the practical applications that you have implemented in various parts of India is just absolutely stunning. Thank you very much. And on behalf of the National Institute of Biomedical Genomics, I will thank you, and I hope that one of these days you will come and visit our institute, even though we are located a little far in Kalyani, but I would greatly appreciate it if you can take half a day off, come and give us a talk and have lunch with us, tour the institute, and we'll bring you back to your home in Calcutta.
I'll come. I visited Kalyani many times.
Thank you so much. This time it will be only for visiting our institute.
I'll do that.
Exclusively for an institute, right?
Yeah, I'll definitely go there. Yeah, thank you.
Thank you.
Dr. Acharya, just now I was telling Ankita, I wish I have her age so that I can go to your place and learn many things. I could follow. I could really follow many things, but many things, I don't know. But I wish I have the age to like her to learn things. I want to learn from Partha, from you. Unfortunately, I have not much time to learn. Anyway, thank you very much for kindly accepting our, agreeing to deliver it. He's flying out of the country tomorrow to USA. So
no, I have postponed because of the war situation. I'm not going now.
Oh yes. That's what I was thinking. How could you go in a flyover? That yeah, that's a good decision.
I'll go later.
Okay, thank you. Very good, excellent. Dr. Acharya, you have to come one day to Acharya, and we want to take your advice for many things.
No, I'll
You
come.
have, yeah, please do that and try to, enthuse our younger ones so that they can carry forward the legacy of Sir J.C. Bose. See, for me, I'm old enough. I tell Partho, he's so far away to come. I feel very sorry. Whenever he comes to Acharya, for him, a whole day. 3 hours driving, 3 hours going back. So it's a pity, Anyway, take care of your health and many more things to see and many more laurels to come. Thank you very much.
Thank you. Thank you very much.
Thank you again, Dr. Acharya. Thank you very much. It was
Thank
a
you,
stunning
thank you.
talk.
Okay, thank you very much. Okay.
Thank you.
Bye-bye.
Bye.
Get it, Jay?